Hey guys, welcome back to Chemistry TV. So today we are going to look at what solubility equilibrium and the solubility what product. So this is going to be a new topic and it's going to be the video one, that is the first video. This first video we are going to actually concentrate on what writing the KSP expression, writing writing KSP expression of any what given source. You get, because this is going to be the first thing you need to learn before you move into what this particular topic. And the particular topic is 100% calculation. So I'll still do video 2, video 3, or video 4 on this topic. But in this video here, the goal of this video here is to what establish how to write KSP expression of any sort at all. Now, when you hear the word equilibrium, it means what it occurs at equilibrium. And for 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 a reaction to occur at equilibrium, it must be what a reversible what reaction. We have done chemical equilibrium what we did something like this: A plus B, so plus what plus B give you what plus B give what C plus what D. Let's see that is what is an homogeneous reaction. You get, so this is called a reversible reaction. These two react together to produce these two. Then these two also react back to what to produce what back this backward what reaction. You get, so I tell that for every equilibrium reaction there must be an equilibrium constant. Is that constant in short? Both the forward and backward reaction react or occur. You get, so that what is called equilibrium what constant. Equilibrium what constant. So if you want to write equilibrium constant here, is homogeneous what reaction, gas, right? So it's going to be Kc equals to what constitution of C is for what the coefficient, what constitution of what D is for what the coefficient, the what constitution of A is for the coefficient, the constitution of B is for what the coefficient. I have done videos on what chemical what equilibrium, so you should go check out those videos. It is at the description below. So the calculation of the what the Kc, the calculation of those equilibrium constitution, calculation of so many things, the Chateliers what principle. I've done tons of videos on that. I believe it at the description what below. So we talk about molar solubility. We also talk about chemical what equilibrium, but this for the year we're talking about dissolving of salts. Now, when writing KC expression, I tell you that the constitution of what constitution of solid and aqueous, solid, so constitution of what solid and liquid are not used in what in writing equilibrium constant what expression, because I tell you that constitution of what solid and liquid are always constant, so that they are always regarded as what as one. So the same thing here, it's still the same reversible reaction, but here a salt is being dissolved. A salt is being what dissolved. A good example here we have silver chloride or silver 1 chloride solid here. Now it dissolve to form it what respect ion. Do you get that? So this salt is made up of what two ion. So the first one always form a positive charge, right? Plus what? Second one always form what a negative what charge. You get that? So it's balanced here. How many mole of silver do we have here? One. Here we have one. How many mole of chlorine do we have here? Here we have what? One. Here we have one here. So if you want to write the K, the equilibrium constant expression, here what do you have here? Equals to concentration of what? Of Ag plus aqueous. Then concentration of what? Of Cl, which is what? Chlorine ion, aqueous. Then over what? AgCl solid, right? Now, because here is what is a solid, we are not going to use it. So we now introduce a constant which called Ksp, which means solubility product constant. Yes, solubility product constant. Use solubility product constant. Now, when I talk about what is salt here, so because here is one, then I will say Ksp equals to not this one here. So we ignore this one here. So we have Ag plus aqueous. Then we have Cl minus aqueous. You get it? So this is just a way to show the difference between what the Ksp and what Kc what expression. Now, but how do you write Ksp expression for a complex, like for salt? You get, how do you write Ksp expression for salt? First, you want to do, you want to understand fundamentals. You want to understand how to split uh, a compound into what the various A to B3 solid here, and you already asked what to split it into what its various ion. Now, how do you do that? Now, first for you must understand that in an ionic compound, so if you're talking about solubility, I should talk about salt, and salt is what is always an ionic compound. An ionic compound is a combination of what metal, what non-metal. So it will contain what a metal, what and a non-metal. What make a compound ionic is when it has what both metal, what non-metal. Do you get that? So this one is what is a non-metal. So the first element here is always the metal. The second one is always what non-metal. Now you want to split them into what their various what ion. Metal will always carry a positive charge. Non-metal will always carry what a negative what charge. Non-metal will always carry what a negative charge. So remember, here we have the numbers of atoms here, right? Numbers of atoms of A here is what 2. Numbers of atoms here of B here is what 3. Please pay very close attention here. Now, if you want to split it here, this one will move here, and this one will move here. So here we have A, which is what the A cube, because we are splitting and you come here 2 what plus B, so move here 2 what minus aqueous. You get? So in saying that, now this is what actually combine to form this compound here. Now let me give you a typical example so you understand. If for example here we have aluminium oxide. So here we have 2O3. It's okay, it's a typical example here. Now this one is formed as a result of what? Al3 plus and what? O2 what minus. So when you combine aluminium and oxygen together, now remember aluminium is 3 plus, because for aluminium to what have the octet electron, it must lose 3 electron, right? While oxygen, for oxygen to have the octet electron, it must gain 2 electron. And whenever a metal give out electron or lose electron, it becomes a positive charge. Do that. So the charge depends on what numbers of electron is going to lose. So here we have Al3 plus, meaning that it will give out at 3 electron. Oxygen here means that it will gain 2 electron. Remember, when the non-metal gain electron, it becomes what a negative charge. So that's how we work out here. You get it? So we have something like this. Now, maybe you are being told to write the ionic expression or ionic equation for Al2O3, and you don't actually understand the electron that they have given out and taken. So what you want to put in mind here is that the first element here is always what the metal is going to be what a positive charge, right? Now, the initial charge is the one that is here, the one that the denominator is carrying, which is 3 plus. So which 3 here? So I move here. Then this one move here. Then this one what? Move here. You get? So it's just like it has changed their what? Their numbers of what atoms here. So here it's going to be 3 plus. Remember here is what solid, right? They which is aqueous. And plus. Also you're going to be O2 what minus aqueous here. You get? So the next thing you want to do here is to balance the equation here. How many aluminum do you have here? How many aluminum do you have here? Here we have 2 aluminum. So here put what? 2. How many oxygen do you have here? Here we have 3. So here we have 3. It will also occur here. Do you understand? So I always want to ask you understand the process here. So since you also occur here, aluminum A yes, I mean 2. So you put 2 here. B yes, I mean 3. So you put 2 here. So how do you write the Ksp expression? But guys, solution product constant forward for the source. Then you have constitute of what the for this guy here, which was 3 plus the rest of the coefficient here 2. You get this one 2. Then here we have B 2 minus aqueous rest of 3. So these are what the Ksp expression for this particular reaction. Hope you understand. 2O3 solid. What are you going to get? You have Al3 plus aqueous, then plus O2 minus aqueous. So you have put here, you put 3. It's okay. So the Ksp expression here, Ksp is equals to consider this one here, Al3 what plus this one 2, then O2 minus this was 3. So what I want to do now is what keep on what practicing, so I will go get used to it. What CaCl2 calcium chloride. I still you should what write the Ksp expression. Right? So you should what write the Ksp expression. How are you going to do that? Please follow me closely. Calcium is what is metal, chlorine is what non-metal. So these two actually belongs to this guy. Remember here we have one, right? This two belongs to this guy, this one belongs to this guy here. You get so here you have what Ca2 plus. Now where is this two coming from for this one here? You get then what aqueous plus. Now here we have Cl. So this there's one here, right? So now we got minus aqueous. Next one to do now is to balance the equation. Calcium here is 1, so put 1 here. Chlorine here is I mean 2, put 2 here. So how do you now write the Ksp expression here? It's very easy. Ksp is equals to constitute of what Ca2 plus aqueous. Then what constitute of what Cl minus aqueous is what 2. So that is it for this guy here. Calcium oxide. So how do you write the ionic expression here? Now, based on what I've done, because I say here is 1, here, because here is 1, here is 1, some people will be trying to say Ca plus O minus, right? Do what some people do here because there's nothing here. But you should know that oxygen is always what 2 minus. It's okay. The calcium is always what Ca2 plus, right? Now because they have the same number here, the 2 always counts 2. So if you want to write here, we have Ca, which is what 2, O, which is what 2. If you should write it here, we have Ca2O2. But you can explain it in that simplest state. 2 can go into 2. Here I have what CaO. Indirectly here we have CaO here, right? The main reason why it's CaO because the ion is what of calcium is 2 plus, while the ion of oxygen is 2 minus. So 2 can go into 2. So that I will got this one here. So it's not just Ca plus now plus O minus. If you do something like this in the exam, then you don't really know what you are doing here because there's no way oxygen will form 2 minus. Also, you always gain 2 electron, right? So you have 2 minus. Calcium always give out 2 electrons. So here we have 2 plus. Do you get? So you really want to be careful when writing the uh, the ionic equation, because if you make mistake in writing ionic equation, then you start failing that question equals here. So what happens is, so if you want to write the Ksp expression, Ksp equals what? Constitution was Ca2 plus Aqs is okay. Then constitution what? O2 minus Aqs. Have Cu B Cu Cu but Cu2O. So how are you going to do that? If you want to write the ionic equation for this, how are you going to do that? So how are you going to do something? If you want to write the ionic equation, how are you going to do that? Now, copper have variable oxidation state. Here we can have Cu plus and what? Cu2 plus. Copper have variable oxidation state because is a what? Is a transition metal. Transition metal only have variable oxidation states. Unlike the this one here, magnesium only have 2 plus. You get, aluminium only have 3 plus. So they only have plus here. Calcium only have 2 plus. You get? So the transition metals are not like what normal what metals, right? So transition metal only have variable oxidation states, which is what which are seeing here copper. So here we can have copper 1 ion and what copper 2 what ion. Cu2 plus aqueous plus what O2 minus aqueous. So what we want to do next to balance the equation is already balanced here. So these two is what combine together to form this one. What about this one here? Now the oxidation state of copper here is what? 1. Because initially if here is 1, remember this one move here, and this one will move here, right? So here we have Cu plus aqueous plus what? O2 minus aqueous. You get, this is that. So now the oxidation state of copper here is what? It's 1. While the oxidation state of copper here is what? It's 2. So you really want to understand this stuff very well. So next is to what? Balance the what equation. If you want to balance the equation here, you have 2 copper here. You have 1 oxygen. So the Ksp expression here, Ksp for the first we're going to do Cu2 plus aqueous. Here out O2 aqueous. Sorry, aqueous. So what minus? So it's called Ksp expression for what? For this one here. Proper for, so here we have Ksp equals to, here we have Cu plus this one 2, then here we have O2 minus aqueous. Yes, so this is Ksp expression for this 2 here. So you really want to, when I write yourself, for example, here we have PO4 2 minus. Called phosphate, we have NO3 and here we call what? Nitrate. You have NO2 minus. Here we have nitrite. Here we have SO4 2 minus. We have sulfate. We have SO3 2 minus. Here we call what? Sulfite. Here we have OH minus. Here we call what? Hydroxide. And we have so many of them. Here we have CrO4 2 minus. We have chromate. Here we have CrO2O7 2 minus. Here we have dichromate. So these are stuff you are actually going to make use of. For example, here we have calcium hydroxide. It's okay. Is solid here, right? If you are being asked to write the Ksp expression, therefore you need to write the ionic equation. You get, you need to write the ionic equation for this one here. Now, whenever you see SO, so OH, they are called polyatomic ions. They are regarded as what? One unit. SO4, they are regarded as one unit. Now, you can view this one as S raised to 2 or 2 minus. So SO4, they are regarded as one unit. NO3, they are regarded as what? One unit. This one can be regarded as Y minus. Do you get that? So we have done monoatomic ion. This is called polyatomic ion. So you don't treat the individual atoms in that ion differently. You treat them as a group. Get? So that is why here is what OH is in bracket 2. This 2 is affecting the whole of them. You get? So if you want to write the ionic expression for this reaction here, calcium is going to be what? Ca2 what? Plus. Then OH what? Minus. Do you see that? The next is what? Is to balance the equation here. So balance the equation. Calcium here is what? Is 1. OH here is what? Is 2. So here we put 2. Yes. So remember here is what? Aqueous. You only need to put this thing here. Aqueous. So next I want to do is to write the Ksp expression. Ksp equals to, here we have, constitution was Ca2 plus aqueous. Here we have what? OH minus aqueous. Is for what? So now let's look at what this question here. It said what? Write the Ksp expression for the following sort. If not that you can do it, you can pause the video and try it. You get and try it. If you can do it. Pause the video, then try it. Then checkmate your answer if it's correct. When when I've done it here, so you can go ahead and pause the video and try it for yourself. So now let's take the first one here. So the first one is what? Session. Oh, shit, son. So look at the first one here. So you have CeI03 for here. So remember, whenever you see a parenthesis like a bracket enclosed on the line, the whole of this one is going to be what? So whenever you see this one here, that is here is what? Here, this one is what is a polyatomic ion. So here we have Ce4 plus aqueous. Do you get that? Because here is 1, here is 4, right? So this one move here, then you have plus IO2 what minus. Now let me show you common mistake some students make. Now they make it of what this 2 here. Now the mistake so many students make is this. When I ask them to what, like some of my students in my class, when I ask them to this one here, the mistake they make, they will do something like CO3 for the number like this. Here we have they will go and make it of this one here, which is Ce3 minus then plus IO minus. This is what they normally the few of them normally do here. This one just like the other one just like what's X. So you're like CEX4. You get it. You're like it's not in the bracket S4, right? Now going to be what? CE4 plus X minus here. You get it. So the other one is what is X. So you're there and I say go to what? X. You get it. So here we have 4. Here we have 1. So it's balanced. So the Ksp going to be what? Because there was Ce aqueous is what? 4 plus actually minus is power. Sorry. So if you want to write the Ksp expression here, Ksp equals what? Consider what Ce4 plus, right? Aqueous. Here we have O3 minus aqueous is what? 4. Yeah, so this is the what Ksp expression for what this sort here. G3 PO4 2. Remember it's solid, right? So this is going to be what? Now if you split it here, this one will move here. So you have Mg2 plus aqueous. This is that plus. And remember, you don't have types for here, so it's going to be PO4. This to move here, so it's 2 what minus. So you have what aqueous. See that? So the Ksp expression, first you want to do is to balance the equation. How many magnesium do you have here? Magnesium is 3. So here you put 3. And PO4 do you have here? 2. So here you have what? 2. Okay. So my Ksp expression, Ksp is equals to what? Because of what? Ng2 plus aqueous. This is for what? 3, right? So you have PO4 2 what minus aqueous. This is for what? Power 2. So now this is now the Ksp expression for this what sort here. You get? So now let's look at this PbXO4 solid. Now what it means is that remember SO4 2 minus do what you already have, right? So it means that this one is going to be Pb2 plus. So they can cancel out. You get? So you have Pb2 plus aqueous plus SO4 2 minus aqueous balance here. So Ksp is equals to what? Concentration of what? Pb2 plus aqueous. You consider what? SO4 2 minus aqueous. Yeah, so this is now what the answer. So you can go ahead and do D and E for me. So you go ahead and do this too for me. Yes. I believe you have gotten tons of value from this video, and this video have really helped you in understanding how to write Ksp expression. Although it's a little bit lengthy, right? But it's worth it because I don't want you to what master the Ksp expression, how to write Ksp expression. That is why we are focusing it here on this video. The next video, I want to move it over to the calculation aspect. So you really want to subscribe to the channel if you have not done that. And please give it a like and leave a comment below. I really want to hear from you. It's very important I hear from you from the other side because it's not speed that is watching it, right? So I believe there's somebody watching there and I really want to hear from you. If this video is what really helpful, leave it at the comment section. You get. So I'll be glad to see that. If you have any question, leave it at the comment section too. Always give it a like so I can spread to other persons here. You can also as well share this video, the link in your various group here, so that those your friends can also actually what see this video, so that they can watch it too. Please try this too for me. I want to see your answer in the comment section. See you in the next video. Thanks.